So let's work out this. So if you followed from the previous one, please just like, share and subscribe. You know how it is. So on this one again, we are trying to derive from the first principle, right? And we're having a bit of a complicated one, right? But let's just use the same ways that we used the previous one, right? So I said if you want to derive from the first principle, first we are going to use the formula that says f prime x is equals to the limit when h tends to 0 of f at x plus h minus f at x all over h. So this is representing this function, but wherever there's x, we are going to place x plus h. So we can see here there's x, we are going to place x plus h, and also here there's x, we are going to place x plus h. So this becomes the limit when h tends to 0 of 2, and then there's x, so we're going to place x plus h. There's a square there, so we're going to say squared, minus 3 and also x plus h. So minus our f at x, this is our f at x, so we can put that in bracket. So this is 2x squared minus 3x all divided by h, right? So let's see now. So after this now, it means that we can proceed. So again, this is the limit when h tends to 0. So it means that now we are going to expand this. So this is 2. We said these are 2 brackets, so let's just put 2 brackets. But if you can expand without using the brackets, that's better. Minus this multiplied by this is negative 3x. This multiplied by this is negative 3h. And then now this and this is negative 2x squared, and this, that is positive 3x. And don't forget that we're having h here. So this is again the limit when h tends to 0. So this would be 2, this multiplied by that, that's x squared. This multiplied by that, that's xh. This multiplied by this, that's again xh. And then this multiplied by that, that's h squared. So now again we can see that there is already something that is the same that you can cancel out. So negative 3x and the 3x will cancel out, right? And we'll be left with here that's minus 3h and then minus 2x squared. Don't forget that we're still having this h here. So again, this is the limit when h tends to 0 of 2 and then x squared plus 2xh, because xh plus xh, that's 2xh, and then plus h squared, and then minus 3h minus 2x squared. So still we are still having all this over h. Again, this is the limit when h tends to 0. This multiplied by that's 2x squared. This and that positive 4xh, and this multiplied by that's a positive 2h squared, and we're still having minus 3h and minus 2x squared. So don't forget that this is all over h. So now how can we proceed from this? So it means that this 2x squared and this negative 2x squared will cancel out, and now we'll be having 4xh plus 2h squared minus 3h all over h. But don't forget the limit when h tends to 0. So this and that cancelled out and we're left with that. So we can see that we're having this term, this term, this term, and also this. So now it means that we can factor out h. So again, this is the limit when h tends to 0 of h, and then 4x, right? And then plus 2h minus 3 all over h. So it means that this and that can cancel out. So this is the limit when h tends to 0. So here you can write that h is not yet equals to 0, right? So now it means that we are having our 4x plus 2h minus 3. But now we said our h is tending to 0, so it means that this can become 0. So now this can actually be 4x minus 3. So it means that our f prime x becomes that. So this is our derivation to this equation. Can you see how simple that is? So if you're having a question regarding this, you can just actually try to do it using these steps. You can actually get how this is done. If you're having another difficult questions that you think that they are too hard for you, you can email them here, and you can also WhatsApp that to our WhatsApp group or WhatsApp page. This is it. So having said that, please subscribe, like, follow, and share. See you on the next one on day 13. Goodbye.